EMC webinar series. What I'm showing up in front right now is the general announcement that's been out for quite some time. We will have 6 webinars, of which 2 have already happened. There's the list right there. The first one I gave on the work of the U.S. National Committee, the IEC. In March, I did on the Smart Grid Interoperability Issues Working Group activity. And the third, which is what we're going to be talking about today, is a review of what happened at the American National Standards Institute Accredited Standards Committee C63 meetings. It's a 4-day meeting series that happened in the Skyway, New Jersey at the IEEE headquarters. And you can see the rest of the year there are 3 more planned, so the dates are shown. And generally what I do is present an hour briefing after I come back from all those meetings. And there are other meetings obviously, but at least I wanted to focus for ACIL members and those that sign up for viewing this on the 6 topics that we published several months ago, and is as shown. So June 1st is the ANSI C63. Now let me close this down here and bring up the website. This is the website for ANSI C63. It's very simple, www.c63.org. And you can see on the left-hand side there's several pages to click onto. What I'm going to do is go right to the C63 Main Committee page, and there's a great deal of information there which I don't have time to go through, but for example, there's the upcoming meeting schedule, the current standard of our status, which I'm pointing to with my mouse, as well as other things such as where to stay and what arrangements we have with local hotels. The number 1 there is the operating procedure. People ask, how do you operate? Well, we are accredited by ANSI, and our secretariat is the IEEE, who is responsible to making sure that we do and follow the operating procedures of C63, which again are accredited and are approved by ANSI and their auditors. So I just wanted to point out the main page. If you go to the subcommittee pages here, you see that there are 8 subcommittees, and you can see the titles. I'm not going to go into the titles, but what I'm going to do is review their reports from the meeting that was held on 12 May 2016, and you'll get a chance to understand the breadth of the activity in every one of those 8 subcommittees. So without further ado, let me close this down and get back to the agenda. This is the agenda for the C63 meeting. It's pretty pro forma, usual introductory material, and what standards have been published recently. We get a report from the secretary, who is Jerry Ramey. He's the secretary. The secretariat, which is the IEEE, is represented by Sue Vogel. You can see I'm number 6 there, and she talks about the status of our standards, which ones are getting a little old, and which ones are, if we don't do something after 10 years, they are administratively withdrawn. And then the status of PINs is the Product Identification Notification System, Initiation Notification System, excuse me. Those are, whenever we do a change or amend a standard, we have to have an approved PINs that is a ANSI requirement. Once that is approved, and it is sent by the Secretariat to ANSI for publishing in their standards review, which comes out about once a month, which says, here's activity going on in C63. Do you want to sign up to be part of it? And that goes, it's on the website, open to the public, and someone in Scandinavia who may want to work on our standard has every right to do so by saying yes and signing up for it, essentially. Of course, if it's a document that is a standard itself, there may be a fee part of that to get a copy of the standard that's about to be revised. I always say that because people realize, keep saying, well, it's an American activity. Well, in fact, it is, and in fact, it's a North American activity because it includes Canada as well. But it's open to people from around the world if they choose to join. Having said that, of course, there are very few. We have one from Norway now, for example, but obviously most of the people, other parts of the world, have their own standards activity in their own country. So let me continue on here. Item 8 is what I'm now going to focus on for the rest of the time we have. So what I'm going to do is I'm going to bring up each one of those subcommittee chairs, which are shown there, have to present a PowerPoint presentation of the status of their work to the main committee, which is C63. And at the first meeting of the year, which this was, they also have to have their scope and their duties and even the title of the subcommittee validated or at least approved by their own subcommittee. And if there are any changes, the main committee has to approve that. So one of the things I'm going to bring up is what are the duties and the scope of these committees. Again, for those that might be interested in joining the activity, it may be of interest. So without further ado, let's go right into Subcommittee 1, which historically has been a major activity because most of the most of the standards started off in Subcommittee 1, standards C63.2 through C63.7. But since that time, there have been 20 other standards, and they are spread around multiple subcommittees. But I think the sort of the flagship products come out of Subcommittee 1, and again, that would be what I'll discuss. So Subcommittee 1 is Techniques and Developments. Zongchen from ETS Language is the chair. The scope is pretty similar to all the scopes. It provides expertise to work on standards that are given to it or assigned to it by the main committee, which is Accredited Standards Committee C63. So new and existing measurement techniques at the moment, the work in Subcommittee 1 is on emission measurements, instrumentation, and so forth only. There is another committee, C63.5, that works on the immunity aspects. So this is sort of an eye chart. There's no need to go into any depth here, but this is the membership list. And if you go to the website that I just showed, you click on Subcommittee 1, and there's a button there for membership. You'll see maybe more easily to read who's on the list. But you can see Subcommittee 1 is very prolific in that it has 30-some members, and from all walks of life, from testing organizations, instrumentation manufacturers, product. We have BlackBerry, for example, and Sony. We have calibration laboratories, Liberty Labs. We even have military on this. So let me move on. The first one I want to talk about is C63.2, which is our instrumentation standard. This goes back because this was under review and ballot in 2015. So the presentation here is, essentially what happened in that ballot. It turns out it eventually got approved, so I'm not going to spend a lot of time on it. And by the way, the approval is, we need more than 50% approval, and then of those that approve, of those that return their ballots, 50% have to approve the document. So let me just kind of go on. There were some negative votes. One came from the military that wanted the standard to go down to 9 killers. In fact, at one point, the question was down to 10 hertz. The document is for work use with C63 standards, and all of our standards have no lower bound than 9 kilohertz. And why 9 kilohertz? That's the start of radio as defined by the International Telecommunication Union Radio Group, which is a treaty organization. So anything below 9 kilohertz is not considered a radio service. And one of the things we do with emission control is protect radio services. So let me continue. Now I'm going to just pick out things as we go along because there's a lot of material there. This is the issue with the lower frequency range, and our specification clearly goes down to 9 kilohertz. You can see the reference to a clause in 1611, which is the instrumentation in CISPR, which is the International Special Committee on Radio Perturbation, or radio interference, which is generally called. It turns out that C63.2, because it goes up to 40 gigahertz, the range between 18 and 40 is only specified in C63.2. Below that, you can use either what's in .2 or 1611 that stops at 18 gigahertz. And again, I'm not going to go into a detail. So there was a question on ranges. You can see the range A, B, C, D, E. We're concerned with B as the natural breakpoint, and in fact 9 kilohertz, not 10 kilohertz. So again, conducted up to 30 megahertz and above 30 up to 18, or to 40 because again, .2 covers up to 40 is shown there. The question was on detector function and bands that's used. I think that's something you may want to look at separately. The only question again was how would the military handle if we only gave them a standard that started at 9 kilohertz and not down to 10 hertz. We asked the military to give us a reason for trying to move it in that downward direction. And you can see even back in May, the last indented bullet item, if no input was received by the date shown above, we'll do as we've done, and in fact that's what happened. And again, there was a question on acronyms and definitions. Believe it or not, the military folks wanted IF, CW, BSWR, and so forth, all of them to be spelled out as not common, which is sort of curious because the continuous wave and void standing wave ratio are clearly things that most EMC people know very well, but nonetheless, they were put in as the acronyms. Now I'm going to move on to C63.4, which is, again, the flagship product that are measuring emissions from digital devices or devices with microprocessors in it. It dates back way to the early 1980s, where it was meant and did replace Measurement Procedure 4 of the FCC, Federal Communication Commission. And that also then was introduced into the IEC CISPR world, and the first edition of CISPR 22 largely mimicked what was in C63.4 originally. And of course there have been some diversions since then, but there's also some commonality that have continued. Pin C, by the way, means that it was a study question. The C stands for committee. In other words, it stays within the committee. It's not announced to the outside world because, again, there's not a clear indication of what's going to happen in the proposed revision. So this is for the full revision of the document, and we had a meeting on it earlier that week. And these are the topics that are being discussed as to possible changes in the document. There's a round-robin test above a gigahertz to show different ways of aiming the antenna. The question was raised, second bullet item there, of what do you do if you have two antenna masts and two antennas, one on top of the other on the same mast? Is there a requirement for spacing to avoid interaction? And that's being addressed as a study. Above a gigahertz, there, in the present 2014 edition of this document, there's a possibility of just laying absorber on the ground plane, because above a gigahertz, at least for 3 meters measurements, 3 meter separation between the equivalent test and the receiving antenna. And the international world has gone to this site VSWR method, which we don't have time to go into. So it's clear that that patch option will be removed. And also, since it's now an auditable activity doing the SVSWR, that makes some sense. This 2 dB rule, which is meant if the emissions change by more than 2 dB as you add cables or plugins or combination thereof, the question is should that remain, or should you should continue adding additional plugins or cables to plugins, because you see the emissions are aiming very close to the limit, and maybe you shouldn't stop it to 2 dB. So things will work on that. The next one, tolerances for dimensional requirements. Right now we say good engineering practices on what 3 meter separation is, or what 10 meter separation is, or what 40 centimeter above the ground plane is, or 80 centimeter for the tabletop. But there's no tolerance on those. And the question is, we have run into assessors that get a tape measure, and if the table is 81 centimeters, they say it's not within specification. Well, it was never meant to be that close, and we're thinking along the lines of plus or minus a centimeter, or something along that. But the good news is it will probably replicate to some extent what's in CISPR 32 on multimedia emission testing. Phase requirements for line impedance stabilization networks. Right now we just have a magnitude and input requirement, input impedance requirement. CISPR has a phase angle, and someone said, well, just simply adopt what's in CISPR. But the problem is the model in CISPR is different than the model in C63.4. So you just can't take a phase requirement out of a document that applies to a model that's different than what's in your document, and that's some of the action going on there. Next one is harmonizing video displays, visual displays, by the way, it's CISPR 22 or not. The question is, when you get to 32, in fact, that should be CISPR 32. Because they're including receivers in multimedia, they have color bars, for example, as well as scrolling H's, whereas in C63.4 we only have scrolling H's. And the question was raised, is there a way in which we could put one display to do a CISPR test as well as a, let's say, a test to Federal Communications or C63.4? And that's being debated. We're taking data right now to see if maybe there's a half screen of color bars and a half screen of scrolling H's might give a sufficient emission maximization. So that's sort of stay tuned. And the favorite topic, next one on bore sighting or aiming the antenna, that's actually part of the first bullet item above. And then, of course, we have a bunch of interpretations that came, and every interpretation had questions, and the interpretations can't change the existing 2014 edition. We can just restate what's there. But the questions delved further, and there's a lot of questions on the use of Annex Delta D on site validation that we are taking on board in the full revision. So the next step is, as you can see there, I'll go right to the bottom. We hope to get this out in 2018, but you know, it's got to go through the voting process and the recirculation and so forth. So this is a what I would call a reasonable approach, but that published in early 2018, could be published later. Or if all the stars line up, it might be in late 2017. I just can't give that judgment right now because we have too many study questions being investigated with measurements by many people. Moving on to the next version of C63.4a, which is alpha. So it will have the identification C63.4a. This is to answer the questions that we couldn't answer in interpretations on normalized side attenuation, which is in Annex Delta. And by the way, NSA by state implies that it is a measurement over a single reflector conducting ground plane. When you go to side VSWR, that is by definition free space, and therefore there will be absorbers on this on the ground plane. So the committees, not only us but internationally, have made the decision that with the conducting ground plane, measurements above 1 gigahertz will be in open free space. But again, since the VSWR is the criterion is within 6 dB, so in essence you're looking at free space within 6 dB, and I won't go into what that means or doesn't mean. This is a document that's mature. In fact, this afternoon I will be on a webinar to close the drafting of this document. The changes that are being discussed is there were movement of the transmit antennas as you did the NSA, 10% in from the periphery of the test volume. Well, it got be confusing. What does that mean? So all the transmit antennas on the turntable will not be moved. The test volume, which is this imaginary cylinder that is placed on top of the EUT and with its cables and so forth, that is the key point for the location of the antennas, not the extremes of the diameter of the turntable itself. We added in the one bullet item there on 3 meters. If you read the present 2014, it says that it goes up to 2 meters, and if you have a product that goes above it, you can't measure in using C63.4. Well, we have these large screen displays that go up to 3 meters, and now that's covered with NSA values that you have to measure up to 3 meters. We put in a 5-meter separation because it's getting popular international. And the rest of it is, I'll let you see it yourself. There were some equations that needed some correction. They aren't critical equations unless you, in fact, wanted to do some calculations on your own. You would may get different numbers than what's in the tables. So those were identified. So the idea is to keep moving on this, and I don't think I have to say too much about it because we're running short on time, but it's imagined that there's 25 people working on this thing. It's a lot of work. And you can read some of the things there. The steps for amendment, this is a limited amendment. The whole document is not open for review. And we're trying to put this on a super fast track to get it out in 9 months. And I'm the chair of the working group. I'm pushing very hard for this to happen. So again, the way forward is shown here to get to that point of publication. I don't think I have to go through the details. Next one that was presented is the antenna calibration document. They held a meeting, and they're on a second recirculation ballot. They had 2 negative responses, which means even though they had 88 comments on the first ballot. So the question was, one of them was, how do you handle the symmetry test, which is taking the antenna and flipping it 180 degrees? And is it different for log periodic dipole antennas or hybrids and so forth? Don't want to go into detail, but right now the fact is it's moving forward on the recirculation ballot. There was data presented on how much pads that connect to the antenna should be used to get the VSWR down below this 2.5 to 1 ratio. And the data essentially showed you need something greater than a 3 dB pad. Of course, you can't put a large number in because then you're going to have no sensitivity to pick up weak signals. And data was presented. Again, the 2.5 is that horizontal black line below. You know, that's at 2.5 on the vertical axis. And when you put the pads in, you can see everything stays very nicely, except a little bit between 30 and 50 megahertz. But if you didn't do it, you get those wild extremes below 60 megahertz. And in fact, all the way up through the top of the bicon range of 300 megahertz. So there were several data to support the case to put this pad in. The next one, the last thing I think I'll do on Subcommittee 1 is on site validation. I just showed you that we're doing something on Annex D for NSA. That was originally supposed to be in C63.25, which is a new document being worked on. Because we are doing so much work in the C63.4 limited amendment activity, which is C63.4 alpha, there was an agreement made at the meeting that this group will focus above 1 gigahertz, and in particular using the time domain version, where not only do you see the site validation, meet the site validation criteria, but if you don't, with the gating function on the time domain, you can find where the area of the semi-anechoic chamber or the fully anechoic chamber needs additional absorber, for example, or is a problem. And since we're talking about 1 to 18 gigahertz, we're in free space, so again, we're talking about fully anechoic rooms with its absorber on the ground plane as well as the other 5 surfaces. There's a lot of background here. The time domain way of doing things is the features in the center there. It requires less time to perform the validation. If you did the site VSWR measurement, you could be there for 1 or 2 days doing it. And it's very difficult because you have centimeter spacing of the transmit antenna, and to have that precisely at those centimeter spacings, most people now have software and a robot, so to speak, that moves the antenna so it can be precisely located at the various centimeter spacings. So the bottom line is, because this is a new approach, it's not been adopted universally, but we think that we have something that's really worthwhile. And once this is completed, I fully intend to move it to the U.S. National Committee for them to submit to CISPR as a additional approach to site validation, even above the site VSWR method. And there's some details on the meeting. 9 people were there, a flow chart, and so forth. One of the things when you use a vector network analyzer, that's what VNA stands for, first of all, you have to use it, number 1. Secondly, you need software or script written to do all of the computation, taking the differential as you move different locations. One of the things we're thinking about doing is having that script available to download for anyone that buys the standard, rather than having to write it themselves. Now, in the document, the actual script is shown there, page by page by page, and to me, that's not very user-friendly if you have to type all that stuff into a software program. So we're hoping that the approach we're taking here will be useful to the customer. A lot of interpretations, and most of them extended beyond what is in the present document, because interpretations cannot change the standard. It can state it in other words, or it can give some background. And that's where the people wanted more than that submitted interpretations. and you can see, I'll just look at the blue. This is blue on my screen. One was on, can we use the CISPR antenna calibration instead of C63.5. The other one was on absorber height. We're talking above a gigahertz now. We limited it to 30 centimeters because we didn't want to block, so to speak, any emissions from a floor standing equipment that might come from the power supply, which is always at the bottom of a rack of equipment. There's the questions on formulas, which we did take care of. Then there's what do you do with the aperture needs of the double ridge horn, and you can read what's shown here itself. And then in Annex N, which is the use of hybrid antennas, it's not a calibration of the hybrid, it's the mechanism to show that that antenna can be used in a specific semi-anechoic chamber or fully anechoic chamber. And fully because these hybrids can go above a gigahertz. So I just want to make sure that that confusion. It turns out that you have to limit the size of the hybrid, width, height, depth, and you have to have a balance that's within 1 dB, and a VSWR less than 2.5 to 1. And if you met all those, then that antenna can be used virtually anywhere. If you don't, you got to go through an exhaustive testing that's spelled out in Annex N to show at least you can use that antenna in a particular chamber because you couldn't meet the general requirements. So I just wanted to point out that there is an interpretation request. So let me close Subcommittee 1, which again is key to the presentation today, and go on to just identify a couple things in the rest of the subcommittees. Subcommittee 2 is definitions, and here's the presentation that was given by the chair, Chris DeLay of the Navy. And you can see it includes not only C63 definitions, but E-cube definitions, because C63.14, which is responsible, which Subcommittee 2 is responsible for, is used by the Navy, and it replaced Mill Standard 463, for example. And the membership is essentially the chairs of the working groups, subcommittees, as well as chairs of working groups. And there's the leadership. And you can see on the far right, they're all from the military. There's the two documents. I mentioned .14, which is the dictionary. And there's another one, Working Group 2, that's looking at a guide for best practices for EMC. And let me just briefly go through those two. .14 is up for renewal, and the nice thing about it, we want to have this in an online database, like the IEEE dictionary. Which is online, rather than having a hard copy, because as you imagine, it could be very thick in paper. So my reaction is that we will get the IEEE to work with us and put that on a database, which would make it a lot easier. You simply go onto a website and type in the definitions, and up pops the what's in .14. .28. The question is, looking at all the standards that are out there on EMC design and testing and so forth, is there a best practice that someone could use, and what is the criterion to judge which of those standards to use? It's a very extensive project. I think it'll take a while, because right now they're just, even in the stage, as you can see, they're defining what they mean by best practice. And that has taken up in the last 4 or 5 months worth of back and forth emails. So continuing on, this is the annexes that list those standards and the best practice. And the idea is the second bullet item there is to have general application as well as application to specific products. And there are some motions to approve. And there's the news. By the way, we do have a newsletter online. I'm not going to go back to the website right now, but if you did, you go on the main committee, you'll find a button for newsletters. And those are kind of nice because they have a very short review of what happened at meetings, such as the one I'm showing you right now. And all the subcommittees have to prepare one, and so it's easy reading. It gets you up to date, at least what was generally discussed or any actions taken. Of course, the detailed work on what happened to standards themselves, you couldn't possibly put in a newsletter. It would take 50 pages. So the conclusion is they're on target, and they're working on this best practice. And he had some backup slides, which I don't think I need to go through. So let me close this down. And let's move on to Subcommittee 3, which I chair, on international standardization. I had a short report, and of course I had to go through the scope, etc. Let me just breeze through that a little bit. Voting members are, for example, all subcommittee chairs. And if I go to page 2, we also include the technical advisors of the CISPR committees as well as TC77 of the IEC. Mainly because let's go to the next one. If you look at the scope, it provides a forum for comparing international standards activities to what we're doing in our own committee. Well, then we better have international representation of people that are responsible for that, at least in the United States. And that's why we have the technical advisors have agreed to be part of the committee, but they're non-voting. And what they do is they call in. We have webinars during these meetings, so they don't have to make the travel, but they are key in indicating, hey, I see this one C63 standard might be useful in one of our CISPR subcommittees, for example, and can state that. And then if that's the case, the next step would be getting it into the U.S. National Committee, the technical advisory group for that subcommittee, and find someone there that's willing to be the champion and present it internationally as an amendment to a international CISPR standard, for example, or a 77B standard, which is the committee that works on the 61000-4-X series of standards. The duties are shown here. There's one standard that we're responsible for, and that's C63.12. And you can see it's a recommended practice for setting limits and test levels. Now, some of the charts in there replicate test levels that are shown in the international standards or for emissions in the FCC, for example. But we go kind of beyond that. We have a test level for severe environments, which is not stated in IEC 61000-4-3. We have a mechanism to show emissions as a function of power supply wattage on large complex equipment, which is nowhere except in .12. But it's a recommended practice. It's not a standard. It's meant to give the manufacturer some additional guidance on what they might want to do beyond meeting the requirements that, for example, in the European Union on the EMC requirements for emission and immunity. Okay, the one thing I just think it's worth pointing here is here's our table of equivalencies that we've identified. On the left column is the C63 documents, and on the fourth column is what international standard that might be applicable or on the same subject. And we have people that are in charge. You see myself there. Since I now have taken over as subcommittee chair, I'm going to find people to champion those. But the idea is to repeat, if there's something, and I'll just pick out one on C63.16 on ESD. That's the 4-2. It turns out the R.16 document has tests for field failures where, for example, you have your laptop and you walk over and connect it to a docking station. That's an ESD event, and that's not shown or even identified in 61004-2. So this is one of our prime documents that we're going to move forward to get it somehow into the CISPR, into the TC77, their subcommittee 77 Bravo. And that's the kind of discussions we have at these meetings. And the other way around. If there's something on uncertainty, let's say in 164-2, that we could use in our uncertainty document, which is C63.23, we can ask permission from the IEC to take extracts from that document. We have a very good relationship with the IEC to get copyright release, and they also have the ability to get copyright release from the IEEE, who holds the Secretariat for C63. Many years ago, this was almost unheard of. Nowadays, as long as you give proper attribution of where you got it from, this release is not overwhelming, the amount of time. So we take advantage of it where we can. There's 3 new documents that we haven't assigned people to other than the chair shown there. We are now into lighting products. LEDs are especially noisy. We're into wireless power transfer now. And the ISM, the 663.31, that is essentially to put in a C63 standard what's in FCC measurement procedure number 5. So when that gets further along, then we'll look at if there's anything abroad that we should be looking at. So I just put some links down there. Don't think there's anything more needed. Okay, let's go on to the next. We'll see how many we can get in before the end of the world here by 1 hour. Subcommittee 4 is a new subcommittee on wireless. Let's bring it up. Okay, make it bigger. And the scope is to look at standards that have to do with measurement of emissions from wireless equipment, and you can see it's beyond that in the scope. It's responsible for writing and maintaining existing imposed standards for wireless and industrial, scientific, and medical devices, which is what I showed you in 29, 30, and 31 just a moment ago, as assigned by the committee, with the parent committee. And there's a lot of people on these. Sometimes these meetings have 40 or 50 people attending a working group meeting. Again, all this information is on the website. So the 5 documents they have right now is .10 on unlicensed transmitter measurements, .26 on licensed. In other words, they have special spectrum. And I already mentioned 29, 30, and 31. A lot of work there, and there's probably over 100 people involved. So just want to give you an idea of what they're working on. There's the scope, etc. So since it's brand new, in fact, at this meeting we're talking about, it was the first time they held a subcommittee meeting. I'm looking forward to more activity coming out of it on C63.29, 30, and 31. Let's move on to number 5, which is our immunity subcommittee. Steve Weitzel is the chair. And the membership is a little bit shorter than others because most of the people came to C63 to worry about emission measurement requirements that the FCC or Canada was imposing. I was the original chair of Subcommittee 5 many, many years ago when we were worried about television interference caused by amateur radio operators, so-called Goldwater-Vanik bill. And we actually worked with the TV industry to have them shield better their turner, because back in those days everything was over the air and there's no cable, and of course the front end of these tuners were wide open and there's not shielding even further downstream. So that was an exciting time to get them to an order of magnitude more immunity in their design. Of course, now with the cable, this is a non-problem. So it's responsible for developing standards for immunity and the instrumentation there too. And these are the 4 projects. C63.9. In fact, I think he talks about it later on, so let me leave that for a moment. Okay, here's the projects. This one is interesting. It's using wireless products in a meeting, a conference room, interfering with the audio equipment. And as you might imagine, the signals that you get in these when you're using a mobile phone or some kind of transceiver. So the test for immunity acceptance is very large. It's 30 volts per meter. And it's in the standards. This has been published for quite some time. So they're looking at revising it to capture the different description of what is being transmitted, what the detector is, because obviously you have new technology, 4G, 5G, and so forth. And the idea there is to have available a DVD where you can download it. It's something that you could download to do this test. 15 is, as you can read the title there, is immunity measurement, but this one is kind of different. We have, if you look at the third, in the middle of the slide, we've included now automotive immunity testing, the SAE tests, quasi-static, proximity, where the source, like a mobile phone, is 2 centimeters away from a piece of equipment. How do you test that? The IEC is working on that right now as well. So I'm sharing this one, and I think one of the other things we have here is to get a particular test level, we indicate the equipment needed to do that, and for example, the need for a particular size power amplifier. And that's not in any other of the standards. They simply say, put down a 10 volt per meter field, and you have to take into account the loss in the cable. You have to take into account the loss in the antenna as it transmits to the equipment under test, and the amplifier, so you don't go into overload and so forth. Well, we give some guidance as to the specifications that might be needed for instrumentation. I've already mentioned the ESD, which, by the way, was published during the meeting. We got an announcement that is published, and I would recommend strongly that people get a hold of that, because it's based on experiences by computer manufacturers of ESD problems in the field that were not covered by just simply doing a 61004-2 test. And so if you're in the testing business, you have customers that say, hey, we meet the requirements, but we still have these problems in pick a place, Arizona, where they have low humidity. Well, this may be very helpful. Dot 24 is an interesting one. Everyone is skirting around how do you do in-situ or on-site testing of humidity, which means you have to have a source, a transceiver of some sort that is affecting a installed product. And you'd be surprised that people try to shy away from this, but you can't really shy away, because a lot of the installations are only assembled for the customer on site. So we're trying to come up with a suite of on-site in-situ testing for both the RF environment as well as setting immunity testing for using available transceivers, for example, like a walkie-talkie that the fire people use to check out a building when they communicate back and forth. So this is at its embryonic stage, but I'm looking forward to this moving ahead. So that is Subcommittee 5, and we should be able to complete the rest of it. I'll bring up Subcommittee 6, which is Laboratory Accreditation. And these are where we have A2LA, NAVLAP, and LAB all present to talk about their situations. I'll go past the scope. These are this is essentially a report without a particular project per se. There is a working group to draft a guide on how do you put together the purchase order for a piece of equipment to be calibrated, and what to identify. A lot of people are just saying to calibration laboratories, calibrate my piece of equipment, my antenna, whatever. Well, I just mentioned if you had a hybrid antenna, we need to know the symmetry requirements. We need to know the VSWR, not requirements. We need to know the actual as a function of frequency. We need to know the VSWR as a function of frequency. If you don't put that in a purchase order, you're not going to get it. So this document is meant to help people, don't miss something. And this is the membership. And this working group I just mentioned is being taken over by the subcommittee chair because the present leader is not available. Then we get reports from the FCC, A2LA. I presented this one from a Policy and Procedure Conference of the American Council of Independent Laboratories, which is our host of this webinar, by the way. And it was very interesting for the people there to see what the FCC commented on vis-a-vis assessors and accrediting bodies. Then there's reports received from the 3 major accrediting bodies. And then, of course, is the action item summary. One thing I'll say about this in here is they present, the top 10 sightings that they have had over the 6-month period between meetings. For example, if they run into test reports as always having a deficiency, they will show us those statistics, and that's very useful. If for those in the audience that are in the testing business to say, well, we better make sure we are up to speed and snuff on test reports, for example. Then, of course, there's always the calibration and things of that nature. I think that's all I wanted to say on 6. Let's move on to 7. We're about there, folks. 7 is unlicensed personal communication services. The big thing there is it's spectrum etiquette, and I'll tell you a little bit more what that means. The biggest issue now is wireless coexistence, where you have multiple wireless devices trying to not interfere with each other. And it's a function of their protocols, the spectrum occupancy, what bands they're using, what channels they're using, and the list goes on. Subcommittee 7 took on that project, and let me go to the actual one. This is the standard they're working on, which is C63.27, and you can see by the title, it's American Standard for Evaluation of Wireless Coexistence. And that means what test technique would you use to show that a wireless device is vulnerable or invulnerable to adjacent wireless activity in the same frequency band. And the classic case is Wi-Fi, where everyone's trying to get into the 2.45 gigahertz band, which is wide open for anybody who's using it. And of course, if everyone's using it, there's a problem. And this heightens the heightened concern for this is in the hospital, in the medical area, where virtually all of the new instrumentation for monitoring patients, for reporting, is all done wirelessly back to the nurse's station or to a site where the doctor can log on. The days of Ethernet connection or getting a printout and walking it over are pretty much numbered. So looking at the bottom there, the working group has had up to 100 members, although obviously there's less people that are active. But this is a hot topic, and this standard is about to go to, well, C63 has been asked, can it go to ballot? And that vote is going on right now. It closes in about a week. My reaction is it will approve going to ballot, and then we'll see what the committee thinks of the document. So on just future activities, well, you can see some of the people they're working with on the wind forum. They're working with Amy, as you can see, associated with advanced medical equipment, actually instrumentation, not equipment. That's where the I stands for in Amy. I was past chair of their EMC committee, but this is the wireless committee, which I'm not a member of at the moment. Okay, last subcommittee, and we're winding down here, is medical device testing, subcommittee 8. And split that up. So it's responsible for maintaining existing standards. Okay, it's assigned by the main committee. I'm going to go past the membership and go into the standards that they're responsible for. First one is C63.18, which is on-site testing of immunity of medical devices to transceivers. Jeff Silverberg is chairing that, and he and I have gone into several hospitals using this technique to determine why an oxygen monitor is misbehaving when a fire guy triggers his two-way walkie-talkie. Well, you'd be surprised at some of the vulnerabilities that shows up with this kind of in-situ testing. .19 is the compatibility measurement of hearing aids with wireless devices, which is, of course, mobile phones. The hearing aid industry is very concerned of being able to use their hearing aid in the presence of also talking on a cell phone, which obviously you can't blame them for that. This standard is the test to show that it can be done. And I think that's all. Go back here. Let me close. So what I've done is gone through all the activity, at least in an overview perspective, in some cases in a little more detail, of what happens in 4 days on face-to-face meetings of these committees by C63, which meets twice a year. Every one of those committees has a webinar accessibility, so they have webinars in between. It's a very active committee, and if you think back 10, 15 years ago, we had 3 or 4 standards that we were handling, and now we're close to 30 standards. And so the pace has significantly picked up, and the idea is to have it at least useful to the United States. But I might say, for example, in C63.4 2014, Canada has picked that up as a requirement for their interference-causing equipment standard, so-called ISIS 003. In fact, we're giving a workshop at the Ottawa IEEE EMC Symposium, in which I have invited a Canadian from their regulatory group to talk about how they ended up using our C63.4 standard and what's the long-term prognosis. So with that, I think I've covered all I could in the short time we had, but I'm hoping that this gave you some insight in what's being done. I showed you how to get to the website to find out more detailed information, because the minutes, when they are approved, are posted. And the end line is that these working groups are open. There's no fee to join. There would be a fee if you were going to be a member of the subcommittee or the parent committee. So it's an open invitation. If anything I showed whets your appetite, is to contact me, and I'll get you in charge, get you in touch with the appropriate subcommittee, or well, I'll get you in charge, get you in touch with those. So with that, I'm going to come to a close of our webinar. And I think Jessica could open the audio just for a moment if there's any immediate questions. And if not, go ahead, Jessica.
I don't see any questions at this point.
Okay. Well,
the mics
again,
are open, though.
Again, the whole purpose of these webinars is to record them so they can be viewed in other times, other time periods, and that's what's starting to happen. So I think it's all there, and obviously for any standards presentation, it's as of the day that I'm talking about it right now. If there's a particular standard of interest, you have to check with the C63 committee, if it's a C63 standard, to see what the status is. And again, that's on the website. We update that on a fairly regular basis. So with that, I close the webinar, and Jessica, you can turn off the recording. Thanks.